happened before. Less than 1 million years ago, it devastated more than half the continent, and it could happen again.
There will definitely be additional eruptions in this area.
And not just one, but a series of monstrous eruptions. 1 million times more powerful than an atomic bomb.
It's absolutely devastating. Everything would be killed.
Destroying thousands of square miles of land and countless lives across the Northwest.
It'll just be over. It'll be toast. It'll be finished.
We go beneath the earth to probe the volcano, reveal for the first time the source of its power, to discover what will happen when the sleeping giant of Yellowstone awakens and becomes a mega disaster. The dance of geysers is one of nature's greatest spectacles. It's why millions of visitors each year come to America's oldest national park, Yellowstone. Its spectacular beauty inspired President Ulysses S. Grant to protect these 2 million acres of northern Wyoming wilderness back in 1872, and it's been a haven for outdoor enthusiasts ever since. Its incredible hot springs, bubbling pools of mud, unearthly ponds, and the most celebrated natural feature, the Old Faithful Geyser, are some of nature's greatest wonders. But beneath this primal beauty simmers a hidden threat. 5 miles below the waterfalls and mountain peaks lies the heart of a supervolcano, a constantly moving cauldron of molten rock the size of Mount Everest. Over countless millions of years, it fills with lava to the breaking point. Like a bomb with a hidden timer, it finally explodes.
We don't know how long it's going to just sit there before it decides to go off.
If sometime in the future it were to erupt, as it has before, the Yellowstone volcano would overwhelm everything within 100 miles and disrupt lives across the globe for years. The first sign of trouble will be increasing seismic activity. The ground would rise as pressure from the molten rock begins to grow.
There would be a lot of ground deformation, and then if it was moving up slowly enough, we would actually start seeing large changes in the geyser basins.
Finally, the lava would shatter the Earth's surface with an explosion 10 times larger than Mount St. Helens. A hurricane of hot gases would spread out in all directions as the ash cloud reaches 80,000 feet into the air. Already larger than anything man has experienced, this would be just the beginning of a Yellowstone super eruption. Within days, a second enormous eruption would begin, then another. Soon, a ring of monstrous explosions 50 miles wide would be spewing molten rock and burning gases across the landscape.
Certainly within 100 miles of Yellowstone, there wouldn't be much that was not destroyed.
High in the atmosphere, the ash cloud would surround the planet, sending temperatures plunging. Global agriculture would fall into chaos. How do we know it will happen? Because it's happened before. The evidence is etched into the geologic record of past supervolcanoes. There are 1,500 volcanoes around the world. But there are fewer than 10 supervolcanoes, the ones with the potential to not only destroy the surrounding area, but to create a global disaster. And Yellowstone is one of these supervolcanoes.
Imagine something 10,000 times the size of Mount St. Helens. It's almost unimaginable.
Unlike a conventional volcano with its crater atop a mountain, Yellowstone's crater is so large it can only be seen from the air. This is the rim of a monstrous crater called a caldera that collapsed into the magma chamber during the last super eruption. It's large enough to hold the city of Los Angeles.
People drive 35 miles, 45 miles commuting to work in that. Well, that's the distance across this caldera.
And this is only the last of 3 monstrous calderas formed over the past 2 million years.
The volcanic history of Yellowstone is really marked by these 3 giant cataclysmic eruptions of the scale that we haven't seen in, history of man, really.
The first eruption vented somewhere around 600 cubic miles of material. And if you took all of that and you spread it out over the state of Texas, you'd have about 12 feet thick of deposits.
The second eruption was hundreds of times larger than Mount St. Helens, and it's the smallest of the Yellowstone supereruptions. The most recent one, known as the Lava Creek eruption, occurred 640,000 years ago. At the time, early man had yet to arrive on the scene. Exotic prehistoric animals roamed the North American continent. 5 miles beneath the earth, however, a magmatic cauldron 3 times the size of New York City was coming to a boil.
There would have been hundreds to thousands of earthquakes becoming fairly large, so there'd be a lot of shaking as the hot rock was moving up.
1 million tons of molten rock heated to 1,800 degrees Fahrenheit pressed its way to the surface. Jets of superheated water suddenly burst through the cracks in the Earth's surface, shooting into the air. Hundreds of geysers were erupting over 500 square miles.
We get explosions out of the hydrothermal system that put holes in the ground as big as a mile across. So they're big events.
But this was just the overture before the main event. After days of increasing earthquake and geyser activity, under mounting pressure from magma and superheated gases, Yellowstone's last supereruption began.
Material may have started to leak out of one side, perhaps forming part of the edge of the fracture zone. As you start to decrease the pressure, it starts to then explode.
With the power of a hydrogen bomb, a monstrous cloud of searing ash and melted rock shot into the stratosphere at supersonic speeds. The heavier debris fell back to the ground, turning into colossal pyroclastic flows.
It was sort of like a hurricane made up of 800-degree ash and pumice and hot gases. Just wipes things out completely.
For miles, these lethal rivers of ash and gas cooked animals alive and brushed forests aside like twigs.
They extend actually outside of Yellowstone into Idaho and into the Teton region. Some of this material flowed down and actually covered parts of the floor of Jackson Hole. So these things extend tens of miles away from the actual eruption location.
For days, the Yellowstone volcano continued to heave tons of molten debris into the air and devastated the nearby terrain. Then, across the caldera, another colossal explosion. Then another. Eruption after eruption began shooting more and more lava and pulverized rock into the air.
Typically, when these eruptions begin, they begin at a single vent, and the event may then get larger, moving out along some sort of a fracture system.
Yellowstone had turned into a super eruption. Its devastation would reach around the world. Yellowstone's last super eruption occurred 640,000 years ago. It started as a single massive volcano, but soon turned into a series of eruptions, exploding with the full force of a supervolcano.
The entire sequence of pyroclastic explosions that formed the Yellowstone caldera may have taken as little as 2 weeks to happen.
Pyroclastic flows slashed across the landscape, obliterating thousands of square miles. Separate clouds of ash fused into a massive column of smoke. Winds drove it across the country, darkening the sky for hundreds of miles.
During the eruption of all this material, that's when the caldera would have started forming.
In a final massive display of nature's fury, hundreds of square miles of mountain, drop thousands of feet into the pit of roiling magma.
The Gallatin Range and the Madison Range and the Mount Washburn Range to the north continued somewhere into the Yellowstone region. These mountain ranges were destroyed. Now, when I say destroyed, I don't mean they were blown to smithereens into the atmosphere. Much of it just fell back into the magmatic system, just fell back into the cauldron, if you wish, up the caldera itself.
We're talking about mountains that might be 12,000 feet high that are now, the ground surface is on the order of 8,000 to 9,000 feet high. So 3,000 foot of mountain that is no longer there.
Finally, after perhaps weeks of constant activity, the Yellowstone volcano subsided. But the devastation was far from over. A global disaster was about to begin. 2.5 trillion tons of sterile volcanic ash drifted with the winds and buried 2,000 square miles of the North American plains, destroying much of the continent's plant life.
The volcanic ash that's ejected high up into the atmosphere and then falls many, many miles away, that goes as far as Louisiana and some of the states along the Mississippi River. So quite an ash cloud.
The lighter particles remained in the air for more than a year, forcing temperatures to plunge across the hemisphere.
It acts as a veil and cuts out the sunlight, and so it cools the climate below. I think there would certainly have been climatic changes due to Yellowstone. We estimated 3 to 5 degrees Celsius drop in temperature, which is quite severe on a global basis.
5 degrees was enough to kill off much of the tropical plant life across the globe. Over the next year, animals died from lack of food as the ash continued to block out the sun. It took years for the planet to recover, for sunlight to reach the Earth's surface, for plants to push through the layers of ash, for animals to repopulate the continent. This Yellowstone eruption 640,000 years ago changed the face of North America. But that wasn't the only supereruption to ever strike the area. Besides the 3 calderas found near Yellowstone Park, geologists have discovered a series of eruptions and supereruptions that extend back 16 million years.
There have been a series of volcanic eruptions similar to those that occur at Yellowstone, and there are all sorts of calderas that are preserved in the Snake River Plain in Idaho and extending back into Nevada.
To date, 15 calderas of more than 140 large eruptions have been mapped. They create a trail running northeast to southwest and are an indication of what geologists call a hotspot. A hotspot is a portion of the Earth's mantle that contains a massive pool of partly molten rock.
There is an area within the Earth's mantle, deep underneath where we live, that is molten. And it's causing a lot of heat to rise towards the surface, and that heat causes melting in the crust. And so we get large magma chambers.
From time to time, as the pressures build, the magma works its way to the surface and explodes.
There are 20 or 30 hotspots around the Earth's globe, such places as Hawaii and Iceland. These are long-lived zones of active volcanism.
The Hawaiian Islands, for example, were created one by one over the millennia by an underwater volcano. Though it appears as if the volcano had moved along the Earth's surface, in reality, the area of molten rock has remained relatively stationary. It is the Earth's crust which has moved. The same is true for the Yellowstone hotspot. Above its magma chamber, the North American plate is slowly sliding to the southwest, about an inch a year. With each new eruption, a caldera is formed and appears to be further to the north.
We find calderas all the way back into northern Nevada, and it's possible that there have been as many as 50 eruptions, just as big as some of the ones that have come out of Yellowstone.
With a history of multiple cataclysmic eruptions, Yellowstone is becoming the most studied supervolcano in the world. And its hundreds of yearly earthquakes, thousands of geysers, and massive magma chamber make it one of the most geologically active regions.
This thing is a breathing system, and it's a dynamic system. So I called it a living, breathing, shaking caldera.
At the heart of these super eruptions is thought to be a mantle plume, an upwelling of molten rock rising from deep within the Earth. But no one could be sure. Recently, however, scientists have been using extremely sensitive monitoring systems to capture data from earthquakes centered around the world. The data has helped create the first 3D image of the source of Yellowstone's power.
Once we put out an array of seismographs with sufficient resolutions, like getting a high resolution CAT scan, we saw that this thing was going off laterally about 150 kilometers to the northwest, and it is basically coming up from a depth of about 600 kilometers.
Yellowstone's magma source begins 450 miles below the surface, and surprisingly not directly under the park, but 150 miles away beneath the Montana-Idaho border.
So it was totally unexpected and would not fit into anyone's textbooks or classic ideas.
As the research continues, scientists are realizing how little they really know about the Yellowstone volcano.
Since humans haven't seen an eruption of this magnitude, we're somewhat challenged to know exactly how the systems work.
One thing is known for sure. If Yellowstone erupts again, pyroclastic flows will destroy everything near the volcano, and its ash cloud would overwhelm humanity across the globe. And predicting its eruption could be a matter of life and death. Yellowstone. Its dreamlike natural beauty may sometime in the future turn into a nightmare. With little warning, the gigantic volcano could awaken and explode, putting the entire planet at risk. Unlike most disasters, such as tornadoes or hurricanes, which are short-lived and localized, a volcanic supereruption in Yellowstone would have global effects for years. Its impact would be on the scale of an asteroid, large enough to change the way we view our history.
For a long time, Earth history was gradual changes, slow changes over long periods of time. And now we realize that every once in a while, boom, out of the sky comes something catastrophic.
Most scientists believe an asteroid caused the disappearance of the dinosaurs 65 million years ago. But new discoveries suggest volcanoes can cause planet-wide devastation as well. One of the early volcanoes fueled by the Yellowstone hotspot left a gruesome graveyard 1,000 miles downwind.
12 million years ago, the wildlife in Nebraska was similar to what we have in Africa today. We have elephants, rhinoceroses, camels, horses related to zebras, all kinds of critters that aren't here anymore.
Their bones, discovered in northern Nebraska, tell a distressing story of Yellowstone's impact. They were found buried under several feet of ash, volcanic debris linked to a super eruption.
We first thought that maybe all these critters had been buried alive in ash, like the people at Pompeii. But the more closely we looked at the fossils, it turns out that that wasn't true.
Most of the fossil bones exhibited evidence of a strange illness, a clue to why so many animals died.
It has the extra growth of bone on the leg bones and on the jaws.
The unusual bone growth is a signature symptom of Marie's disease, a rare lung condition resulting from breathing large amounts of dust or ash.
Well, this is a jawbone of a camel from the ash bed. This shiny bone here is healthy. It's normal fossilized bone. And you can see where the healthy bone stops and this new growth begins. You can see the color changes and the texture changes. It looks like a sponge. And this is the diagnostic feature of HPOD, or Marie's disease.
Voorhees believes that ash from the Yellowstone hotspot caused Marie's disease in these animals.
Ash is nothing but very small pieces of glass. That's how you can tell volcanic ash from other types of fine powdery rocks, is that volcanic ash sparkles because it's made out of little teeny pieces of glass.
During a super eruption, the tremendous pressures cause the molten rock to explode. It turns the rock into tiny pieces of glass, which drift with the wind and land hundreds of miles away.
Just as soon as the volcanic ash fell, the whole landscape for thousands of square miles was covered with this very fine powder. And every step that those animals took, they would raise a cloud of ash. And they just kept breathing it day after day after day. So what we think happened to the animals is that they breathed this material night and day until their lungs just gradually gave out.
Most of the animals on the Nebraska plains suffocated on the ash within a week of the eruption. This from a supervolcano 1,000 miles away.
Volcanoes can kill at a distance. I really wouldn't have bet 20 years ago that a volcano 1,000 miles away could actually cause mass death, but ashfall has made a believer of me.
More recently, the 1815 eruption of the Indonesian island of Tambora proved ash could kill indirectly through dramatic climate change. 50 times larger than Mount St. Helens, the impact of the Tambora volcano was overwhelming. The eruption reduced the mountain by 4,000 feet, as nearly 150 million tons of ash and debris were ejected into the air. The ash cloud could be seen for hundreds of miles.
The cloud went over India, darkened the sky, and caused the temperature to go down. The temperatures went below freezing.
It took almost a year for the ash to spread across the rest of the globe. But when it did, the results were staggering. A New England newspaper from 1816 published this account.
Snow and hail began to fall about 10 o'clock a.m., and the storm continued till evening, accompanied by a brisk wind.
This was June 15th.
There was, in some places, essentially no summer. In the eastern United States, there was snow and ice in June, July, August. They replanted the crops died, they replanted them again.
The unusually frigid weather reached Europe, some 9,000 miles from Tambora, throwing life there into chaos.
1816 was the last time there was widespread starvation in Europe. That's never happened since. And it's almost certainly involved with the eruption of Tambora.
And the Tambora eruption doesn't begin to match the fury of a Yellowstone super eruption.
The Tambora eruption is on the order of 50 to 100 times smaller than these large sort of supervolcano eruptions out of Yellowstone.
Even smaller than Tambora was the 1991 eruption of Mount Pinatubo in the Philippines, which devoured villages out to 200 miles. Yet despite its modest size, Pinatubo altered the global climate for years and has been linked to the destructive hurricanes Andrew and Iniki.
After the eruption of Pinatubo, there was a definitely measurable change in the global temperature as a result of that eruption. It was on the order of 2 degrees for the year following the eruption.
It may sound trivial, but a 2-degree change in global temperature over a long time could create unusually severe storms and kill off all but the hardiest plant life. Pinatubo was 100 times smaller than the last Yellowstone super eruption and had cataclysmic effects across the globe. Imagine what Yellowstone would do. In recent geological history, only the colossal eruption of Toba on the island of Sumatra can match the size of Yellowstone. And that eruption some 70,000 years ago may have nearly destroyed the human race.
Well, Toba is the largest supervolcano that we know about. There's now a large lake called Lake Toba, which is the hole out of which the eruption came.
It likely erupted for 2 weeks, dropping ash 6 inches deep on the subcontinent of India. But Toba's greatest impact was felt halfway across the planet in Africa. Around the time of the Toba eruption, it's thought the population of early man was catastrophically reduced. It appears a bottleneck or a contraction of the human population occurred, reducing our numbers from possibly hundreds of thousands to just a few thousand.
We know from the genetic data that something happened in the human history, in the history of our species, that reduced the amount of genetic variation a lot. And the argument is all about what was the nature of that event. One possibility is that there's some catastrophe that happened 70,000 years ago, like the Toba supervolcano, that just wipes out plants and animals and humans all over the earth until there's hardly any of them left.
The massive eruption of Toba, more than 25 times larger than Tambora, likely created a catastrophic change in climate. Ice core samples suggest that the average temperature may have dipped as much as 20 degrees for years after the eruption, likely killing off plant life across the globe. Hardest hit would have been tropical areas like Africa.
Africa is where we were at the time, and so it affected us directly. And secondly, it's the tropical vegetation that never experiences cold temperatures, so has no adaptations for cold temperatures whatsoever.
The frigid temperatures killed off much of the African plant life, and the resulting famine may have decimated much of the human race. It may be that the 6.5 billion people who inhabit the Earth today are the direct descendants of the few who survived the Toba eruption. If a single eruption like Toba is powerful enough to almost destroy the human race, what would a similar supervolcano do today?
When a large giant eruption were to occur, I think there's little that man can do about it. The biggest thing we have to do first is understand them.
That's why scientists are studying every aspect of the Yellowstone volcano. What they discover may be the key to our survival. For most of us, Yellowstone National Park is one of our greatest natural treasures. But what lies just below the surface could destroy it all.
The sense of scale of the catastrophic eruptions for Yellowstone is very hard to grasp.
640,000 years ago, a supervolcano in Yellowstone devastated the region. Today, scientists monitor the ground movement in Yellowstone to determine if and when another super eruption might occur.
We don't know exactly what happens before a super eruption takes place and how much time one has before the eruption actually goes off.
The rise and fall of the ground, for example, could indicate the movement of magma below, a possible danger sign. These movements cover very short distances over long periods of time. So scientists have placed throughout the park 12 global positioning satellite monitoring stations that can detect ground movements within 1/4 of an inch. Geologists have also gained a bird's-eye view of the situation.
We use satellites in this case to take pictures of the ground as it's moving over time. And so we can compare two different passes of the satellite that are perhaps a year apart and make a map of how much different spots on the ground have moved.
With these tools, geologists have been able to document changes in the caldera, its constant rising and falling over time. According to recent satellite data, much of the caldera is being lifted up.
What we've seen has been uplifting now at rates of 6 to 8 centimeters per year. Those are very high rates.
The most dramatic uplift is just north of Yellowstone Lake, in the area geologists call a resurgent dome.
And we have within this caldera these orange areas here. These are resurgent domes. These are areas that are uplifted while the caldera was collapsing and subsiding.
Geologists believe that these two areas were lifted up by the magma chamber as the caldera was formed. It's thought that some magma is still inside these domes, holding up these areas. But they couldn't be sure until now. We've seen this model of the Yellowstone magma plume, the tube through which molten rock from the Earth's core reaches the magma chamber sitting on top of the plume. Using similar data, geologists have created this 3D illustration of the magma chamber as it sits below the Yellowstone caldera.
This is a three-dimensional image like a CAT scan or an X-ray of the Earth. is giving us an image of what we think is the magma system that drives Yellowstone.
This U-shaped chamber is thought to contain more than 300 cubic miles of partially molten rock, 100 times larger than Pinatubo's magma chamber, and is just 5 miles below the surface. More importantly, the area of the most dramatic uplift spotted by the satellites is directly above a peak of the chamber. This suggests the magma chamber is expanding, pushing up against the Earth's surface at this peak. The other area of striking ground deformation is near the Norris Geyser Basin, the hottest and most unstable thermal basin in the park.
Norris Geyser Basin is one of the most dynamic of the hydrothermal areas at Yellowstone. It's always changing. We're always noticing new things that are happening.
Just a few years ago, satellite images showed Yellowstone's greatest rise in this area. Recently, however, it's reversed its direction and is now subsiding.
It's not actually within the Yellowstone caldera, yet it's one of the highest temperature thermal areas in the park. And it is possible that there is some magma extending to the north beneath that region.
The source of the basin's volatility could be magma, or another key component to volcanic activity, earthquakes.
The earthquakes are essentially the heartbeat of the system, are an integral part of the active, if you wish, mountain building and volcanism of Yellowstone.
Like smoke and fire, volcanoes and earthquakes go hand in hand. The pressure from the magma, which can explode into a volcano, also forces the ground to shift, causing earthquakes. They can be the telltale signs of an impending eruption.
The two main precursors to a volcanic eruption, seismicity and ground deformation, are very carefully monitored in Yellowstone.
In this computer model, each red dot represents an earthquake. Typically, hundreds of earthquakes are detected across the park each year. In recent years, the greatest earthquake activity has been centered under two areas of the park.
So you can see we have earthquakes that are concentrated on the north side of Yellowstone, coming down through the park, and then out extending on the east side of the Teton Fault right here.
What concerns geologists is when a center of earthquake activity overlaps an area of shifting terrain. At the Norris Geyser Basin, that seems to be what's happening. There are dozens of fault lines at this spot.
That's very critical because if magma is starting to move up, we would expect to see a bulging in an area and associated earthquakes as the ground starts to crack.
The fear is faults that make up the earthquake zone could crack under pressure from the magma below, releasing an eruption. Geologists are also watching the park's geysers, hot springs, and mud pots, looking for drastic changes in temperatures and chemical content. Anything that might indicate a major movement of magma. At the moment, geologists do not believe an eruption is imminent. But if the water temperatures were to rise, the ground begin to swell, or there were an increase in earthquake activity, another Yellowstone eruption could be building.
I think that we are smart enough as geoscientists now that we would probably have weeks to perhaps months of indicators before anything like that would occur.
However, predicting the precise timing of an eruption is far from simple. Scientists have been fooled in the past.
We've seen it in Yellowstone. There's bulging, there's vibrations, there's increased seismicity. There's all the things one would expect and go, oh, uh-oh, we're in trouble. And then, nothing.
Therein lies the problem. All we can do is monitor the volcano, but it may not be enough to predict a possible eruption. Mount St. Helens was the most scrutinized volcano in history, and it exploded before the area could be cleared, killing 56 people. At Yellowstone, despite its remote location, a giant eruption could put thousands of lives at risk.
Remember, we have, maybe 100,000 people per night staying in the Yellowstone Teton system in the summer. This is equivalent to a community of a modern U.S. city that are compacted into this zone of potential eruption, so the exposure is rather high.
At Yellowstone, we may be on the edge of a precipice, and the question is not if it will erupt, But how and when?
Nothing you can do about a volcano. If it's going to go off, it's going to go off. And the effects on civilization are going to be drastic.
We may not be able to prevent an eruption, but when the molten rock begins to move up toward the surface, will all the scientific data warn us in time? Now, using historical records, scientific models, and the latest in computer technology, you will witness the devastation that follows when the giant volcano of Yellowstone erupts. For 70,000 years, the Yellowstone volcano has remained quiet. But sooner or later, its magma chamber will slowly fill with millions of tons of molten rock. Gas pressures will push up toward the surface, bringing the volcano to the breaking point.
This is one of the rules of geology. If it happened in the past, it'll happen again in the future. We know there's going to be super eruptions, and probably one at Yellowstone, and it's going to have catastrophic effects.
Now, using computer models and the latest scientific information, you will experience what would happen if the largest volcano in North America were to erupt.
When that eruption occurs, there is no doubt whatsoever that parts of the northwest of the United States will be completely and comprehensively devastated. It'll just be over. It'll be toast. It'll be finished.
The first indications of a Yellowstone eruption will be rumblings heard underfoot as dozens of small earthquakes begin. The ground begins to rise from the pressure of the expanding hot waters, gases, and surging magma. The temblors grow in strength, spreading across the entire rim of the caldera. All the tourists have to be cleared from the park. Officials send out warnings to towns within a 100-mile radius, the danger zone of a Yellowstone super eruption. The cities of Bozeman, Montana, and Cody, Wyoming prepare for the worst. Throughout the park, new cracks in the ground release huge geysers, spouting superheated water hundreds of feet into the air.
The earthquake shaking itself will create fractures and cracks, allowing more material to come out.
The last of the tourists and park personnel must rush to leave the park, trying to reach a safe distance some 100 miles away before the caldera lets go. They may not have enough time. Lava first appears, oozing out of cracks in the surface. Then, steam and ash explode hundreds of feet into the air. But instead of this relieving the pressure, it pushes the volcano over the edge.
The magma contains a lot of gas, and if you're able to depressurize the system rapidly, then the magma will lose its gas explosively and you can have a very, very large eruption.
From 5 miles below the surface, molten rock heated to 1,200 degrees bursts into the air.
It begins to erupt, and you see these flows coming out sideways, and there's nowhere to go.
Like a hurricane of ash, pyroclastic flows rip along the ground at 100 miles per hour. For those who left the park within the past half hour, their luck has run out. 50 miles away, the 30,000 residents of Bozeman, Montana watch in horror as the plume of ash and rock reaches into the sky. If they know anything about Yellowstone's past, they'll know they have little time before their city is devastated.
The pyroclastic flows may go out as far as 50 to 100 miles away from the volcano. And so you'd see the pyroclastic flows coming across ridge after ridge after ridge, and then finally hitting where you are. So locally, regionally, it's absolutely devastating. Everything would be killed.
The sky begins to darken as the ash cloud obscures the afternoon sun.
The material is going to explode, violently to the surface, and the material's coming out at supersonic velocities. And the finer materials go 50, 60, 80,000 feet into the atmosphere.
Then a second eruption begins on the other side of the caldera. Then another. It is no longer a simple volcanic eruption. Like it did hundreds of thousands of years ago, Yellowstone builds into the largest eruption known to man. The giant cauldron of magma spews 1 million tons of melted rock thousands of feet into the air as several volcanoes continue to erupt. Wave after wave of burning ash and debris destroy everything in their paths. With so little warning, nearly 400,000 people are at risk. And it gets worse.
Material falls back onto the surface of the earth, and so you get ashes that are maybe 10, 20, 30 feet deep around Yellowstone.
A brilliant summer afternoon begins to look like a blustery, snowy night. The weight of the falling ash collapses roofs across the states of Wyoming, Idaho, and Utah, killing thousands, while a cloud of lighter ash 1,000 times larger than the one produced by Mount St. Helens drifts eastward with the wind.
There's so much ash put into the atmosphere, and it gets distributed so globally that it would cause disruption to air traffic, not just near the scene of the eruption, but really globally for a period of time.
The ash goes in the jet engine and becomes ceramic and coats the jet engine. And there have been horrifying descriptions of airplanes just losing their power and diving while the pilots try to figure out what to do to start the engines again.
Air travel grinds to a halt as the ash cloud reaches the upper atmosphere. And then, the deadliest part of the Yellowstone eruption begins.
There's lots of ways you can die in a pyroclastic eruption. And one way is to inhale the stuff and inhale these sharp pieces of glass. They attack the lungs, they attack the bones, they kill you from the inside.
Across the country, masks are supplied to protect people against the ash. But farm animals have no protection. Within weeks, vast numbers of the country's livestock die, like the animals that roamed the Nebraska plains 12 million years before. And volcanic ash covers much of the Midwest's farmland.
You can't grow anything in that ash. Fresh volcanic ash is sterile, like Mount St. Helens just after the eruption. And so it wipes out the breadbasket of the world, breadbasket of Canada, breadbasket of the United States.
And the effects could last for years.
Recovery is going to be a long process. So where does food come from in the meantime? I don't know.
Millions of people could die from starvation related directly to the ashfall in America's Midwest. Countless more would suffer as the ash cloud drifts across the globe, dramatically changing our climate.
It's quite likely that the climatic effects would be much worse than humans have experienced in the last couple hundred years.
The Toba eruption suggests that ash particles would remain in the atmosphere for 6 years, radically cooling the planet. It could mean snow in June, frost in August, and the killing off of crops for years to come.
Imagine 6 years without a growing season. What does that mean? I foresee a very difficult period of time when civilization would really be strained at the roots. This would be the most severe condition that human beings have ever met.
It may not happen for thousands of years, but one day history will repeat itself. The slumber of the Yellowstone caldera will end, and the planet will face potential catastrophe. Hopefully by then we'll be prepared. But if not, it could be one of nature's greatest mega disasters.